Today we're going to talk about the care and maintenance of theater lights. And for purposes of discussion, we'll say that there's two types of lights that we use in the theater. This is very technical, so I need you to pay attention. The two types of lights we use in the theater are the kind that go like this and the kind that go like this. The kind that go like this are called profile or spotlights, and the kind that go like this are called floodlights. Here at Seaside High, what we use mostly are these kind of lights, which are in the floodlight category. These particular floodlights are known as Fresnels, and the reason they're known as Fresnels is because of this lens right here. This is a Fresnel lens. Now, if anybody has ever been to the Maritime Museum, they will have seen another Fresnel lens. It's up at the top, and it's in many pieces, but it's the one that runs a lighthouse. And the reason it runs a lighthouse is the purpose of a lighthouse is to send a small beam of light as far out as possible into the sea to warn ships that there's an impediment in land coming up. Well, this Fresnel lens serves mostly the same purpose. Its job is to take the light that comes straight out here and spread it a little bit and make a nice soft edge. Same design, but a different use for the similar design. So this is a Fresnel, and this Fresnel is a 6-inch Fresnel, and it's called a 6-inch Fresnel because the diameter of this lens is 6 inches. Pretty clever. There's also 8-inch Fresnels, 10-inch Fresnels, 12-inch Fresnels, and in movies, things called 2Ks, 4Ks, and 8Ks, which are about the size of garbage cans. They would not fit very well in this room, and they would make more heat than we necessarily need. The problem with having a dirty lighting instrument isn't that it gets all over your hands, besides the fact that it gets all over your hands. The problem with having a dirty light is if there's dirt here, less light comes out. If there's dirt inside, there's less light to come out from the reflector. So we need to clean all of the light, sometimes for aesthetics, sometimes for illumination. And we're going to start by cleaning the outside of the lighting instrument. Why? Well, this is aesthetic, so that it looks pretty. And so the people who come into the audience look up at the lights and don't say, "Ooh, look at the dirty lights. They must not care about their theater." Of course we care about our theater. So we're going to clean the outside to make it look pretty and take all of the cobwebs out, destroying entire ecosystems in the process. Goodbye, spiders. Farewell, little gnats. So we've cleaned the outer casing. We've cleaned the back where the vent is. I'm cleaning around the inner ring, and I'm cleaning around the gel frame holders. Now, isn't that an attractive light? Pretty, huh? Now I'm going to open up the front of the light and expose the inside. You see the back of the lens is not necessarily clear. It's frosted and it's stippled, and the reason that it is to make the outside beam of light soft, so that when you combine one light with another light across the stage like we do here, one beam doesn't make a sharp line across the actor's face as he enters the next beam. Instead, there's a soft glow, and as the actor walks across stage, he or she will be evenly illuminated, and that's our major focus here at Seaside High: illumination. Very little artistic abilities, but lots of illumination abilities, and that's what we're going for. So since we want maximum illumination, we want to clean all the parts that illuminate. This is the lamp. Many may think of this as the light bulb, but they would be wrong. The bulb is only the glass envelope on the outside. The entire unit is called a lamp. Therefore, when you ask that humorous stage joke, how many stage electricians does it take to change a light bulb? The answer is, it's a lamp, damn it. So, first thing we want to do is we want to clean the light, we want to clean the bulb, and Lysol is probably not the thing to do it. I would use alcohol or Windex to clean this, because this isn't glass, this is quartz. And quartz takes a lot higher temperatures than glass does, which is why we use it in the theater. Inside the lamp is a filament. Now, filament, when Edison first formed his first light bulb or lamp, the first filament was actually a piece of carbonized cotton that had been charred so that it conducted electricity. And as it conducted electricity, it went through the filament, and because the pathway was so small, the electrons tended to heat up and incandesce. So an incandescent light makes electrons heat up to the point where they glow, and that's what a filament does. This is a specially designed filament. This filament is made of tungsten steel, which glows at a lot higher temperature than glass, for instance, can accept. So we have a quartz envelope and a tungsten filament. So they call this tungsten halogen or quartz halogen lamp because inside there's a halogen or inert gas. Too much information? Yes, too much information to just clean. But know that if you were to not clean this lamp and put a thumbprint on it, you would leave behind the oils that are on your hand. If you do that, when you plug this lamp in and conduct electricity through it, what's going to happen is the place where the oils are is going to heat up quicker than the surrounding quartz. And as it heats up, it's going to make that quartz molten and it's going to glow and blister. And pretty soon that's going to be the weak point in the envelope and it's just going to blow out. So we try at all costs to avoid touching these quartz envelopes so that we extend the maximum lamp life. Lamp life on these is around 300 hours. Lamp life on these with a thumbprint on them is around 100 hours and a spectacular display of fireworks when they go. So we would try to avoid that. If you do happen to touch a quartz envelope, it's very advisable to get an alcohol swab or Windex and try and wipe the envelope off, simply like that. And then it'll take the oils off and keep it from blowing. I have a collection of these that have blown in my shop at NPC, which I call the Hall of Flame. The most spectacular ones with colors and pieces where you can actually see people's thumbprints or when the filament has been extended into the glass itself. Very exciting. The first thing we do, therefore, is clean the glass envelope with alcohol or Windex. Inside of the light, you'll see that there's a reflector so that we don't lose all the light that's going, because the lamp will emit incandescence in 360 degrees. Well, okay, except for down here. So almost 360 degrees. But if we didn't have a reflector, all the light that went this way in the lamp would be lost and it would heat up and it would burn our hands. So we put a reflector in the back, and this reflector is known as a spherical reflector. If you were to continue the contours inside of the lamp, this little arc would create a complete sphere. Taking that cut of it, or the spherical reflector, means that all the light that hits this bounces straight out. There are other designs of reflectors, in, for instance, spotlights, where all the beams of light converge ahead of the lens. But that's another story for another day. Know that this is a spherical reflector. It's designed, just like a lighthouse, to send all the light straight out. Then it's the job of the lens to spread it a little bit and soften the edge. So we want to make sure that the reflector is clean too. And if you were able to zoom in really good on this, as the camera can do, but you people cannot, you will see that there's a little bit of dust on this. This little bit of dust means that we don't get 100% of the light out of it. What we get is less. So, with a simple application of a Lysol disinfecting wipe, we'll see how this works. And a dry cloth, because we don't want to leave the fuzz on. We have cleaned off the dust and made the reflector, hopefully, visibly cleaner. So we've cleaned the lamp, we've cleaned the reflector. The next thing to do is clean the lens. We'll take our Lysol disinfecting wipe and then the dry cloth. In most cases, I would, as always, use either alcohol or Windex to do this, because they're designed for glass and they're designed to evaporate cleanly. Some lighting instruments, modern instruments, say don't use Windex at all, only use alcohol. And there's one manufacturer that notes that specifically. But that's not to worry about here at Seaside High. You can use whatever will clean and wipe off. And you've seen that I've cleaned the back of this lens, so all the stippling is now clean. The next thing that I'm going to do is clean the front of the lens. And each of these little rings is its own curve. If I were to take the curves of these and basically pop this out like an expanded cup, like a camping cup, you would see a curve that pops out in a convex fashion, about 2 inches. And the reason that they've cut that extra glass out is that was just glass heats up, and as it heats and cools, if there's any defect in the glass, it'll crack. So over the course of the show, a thick lens would just crack. So they took they kept the curves intact, and that's what I'm cleaning off now, each individual curve. But they took out the unnecessary glass in between. So they just collapsed the cup into its flat form while keeping the exterior curves really nice. So now we've cleaned the dirt off the outside surface. We've cleaned the dirt off the inside surface. We cleaned the dirt off the lamp, which emits the electrons and the photons, and we clean the reflector, which allows them to go out the front of the light. This is as clean as this is going to get. So the next thing to do is to replace the lamp. Looking closely at the end of the lamp, you notice that there's 2 little ears off the bottom of this base, one wider than the other. This is what's known as a medium pre-focus base, and it fits into the holes inside the socket right here. And it only fits one way. The wide ear goes into the wide hole, the narrow ear goes into the narrow hole, thusly. It pushes, and it turns a quarter of a turn, and now we can see that the flat part of the filament is facing directly forward and directly backwards. So we're getting the maximum output forward and the maximum amount reflected in the rear, and so as much light as we can get is coming straight out of the front.